Okay, so in this discussion, I'm going to go over some basic types of insulation, how they work, and how they are installed or used. So insulation, again, this is a review. The main goal of insulation is to stop heat flow, or to prevent or slow down heat flow. And it does this mostly through prevention of conduction, but also convection and radiation. And this is primarily done through the use of air pockets. We've talked about this before. But this is an electron microscope scan of fiberglass bat insulation. And then this is open and closed cell foam, which we'll go over here in a minute. And if you remember, we've talked about how heat conducts through insulation like this. A little, there we go. Or pen, right? So if heat wants to go from this side to this side, it's going to have to go through all these different air pockets, right? So this heat is going to hit this fiber, it's going to warm up the fiber, and then that's going to radiate energy out. It's going to conduct energy over, convect energy over, and then there'll be some conduction as well. We'll travel through here, but it's going to take a while, and then eventually the heat's going to make its way through here, and then you hit this fiber. It hits that fiber, and then that fiber has to warm up first, and then eventually that's going to radiate some energy out. It's going to convect some energy through this air pocket. It's going to conduct through the fiber and to this fiber and this fiber and this fiber and so on. So as it tries to go through that insulation, it keeps hitting these fibers and then air pockets, and that makes it very difficult for the heat to travel through. And the same thing happens over here with a spray foam, right? So we have these air pockets, and for heat to go from this side to this side, it's going to have to go through, warm this up and go through this air pocket, warm that up, go through that air pocket, and so on. So it's all about the air pockets is the point, okay? All right, so that's a review of how insulation works. So let's go through some different insulation types. You're just going to jot these down. You don't need to know all the details of all of these, but it certainly will help to know the basics. So first we have fiberglass bat. Okay, so fiberglass bat is it's made of fiberglass, which is extruded glass. Pretty decent R value, about usually rounded to around R3 per inch. These are really cheap, really easy to install. Not a decent insulator, but not a good air barrier at all. Okay, so it's very loose and air can flow right through it, but it is a solid insulator. Then we have loose fill cellulose, which you just blow out using, so at the end of this hose is a machine that sort of chops up this cellulose, which is just ground up old recycled newspapers with some chemicals in it. And then it just sort of sprays it out through some air compression, blows it out, and then you just gradually fill in whatever space it is you are insulating. So this is a decent insulator, R 3.2 to 3.6 per inch. By the way, there's a range of R values because it depends on if it's compressed, if it's wet, the exact type of insulation it is, how well it was installed, if there's things inside of it, like that sort of thing. So that's why you have a range of R values. Very inexpensive, easy to install, but you need the machine, and it's also not a good air barrier. Then we have dense pack insulation, which you can see here. This is actually a hose that's used to install inside a stud bay of a building, and that sort of shoots the insulation up into that in between the wall, the inside and the outside wall, and it sort of sticks there and forms this what's called dense pack. So again, that's a pretty decent insulator. It takes definitely some training to figure out how to do this. But that actually does form a pretty good air barrier, so it's pretty good at preventing air from moving. Then we have what's called polyisocyanurate, which is usually just called polyiso. This is the best insulator per inch. This comes in a board, usually has foil on the outside, about R7 per inch. Good air barrier. It's not so good for wet areas because this will actually absorb water, but definitely good for dry areas of the building. Then we have vermiculite, which is something you might find in old buildings. Vermiculite are these little like popcorn type things. Not particularly good insulator, but the really big problem is these are completely discontinued because if you find vermiculite in a building, it most likely contains asbestos, and so you want to have it removed professionally if you find it in there. Then we have XPS, or Extruded Polystyrene, which is often called blue board. It could be pink board. It actually just depends on who manufactures it. And these are pretty solid insulator, about R5 per inch. Usually a good air barrier. And then generally pretty water resistant, so they're good for wet areas. And you'll see this a lot of time in below ground applications. Then you have your EPS, which is just styrofoam. Solid insulator, about R4 per inch. Not a good vapor barrier, not a good air barrier. It does prevent some airflow. This is super cheap, but it's just not used that much because it's not good underground, and it's not as good of a insulating value as a blue board or the XPS. Then we have our two-part foam. So this comes in two canisters that are different chemicals, and when the chemicals are separate, they're liquid, at least when they're pressurized. And then you have this little, you basically hook them up to this machine, and you hold this trigger, and what it does is it mixes those two chemicals and sprays them out. And when those two chemicals mix together and hit the air, they pretty quickly turn into foam. Now this is really good. There's a couple different kinds. There's closed cell foam and open cell foam. Closed cell is highly insulative, R6.5 and even R.7. These are really nice because you can spray these upwards on ceilings and inside of walls, and they'll stick, and they form a good air barrier, and they provide a lot of insulation. Now you can see you need a specialized suit to apply these because it is toxic to breathe in, so you have to let it form and coalesce into foam, and then it's mostly fine. But when it takes a specialized skill to install these, but it is really good if you really want to make it super efficient and you don't have a lot of space. Okay, so here's just a summary. I'm not going to go over all these, but this just summarizes everything there. The ones you see most frequently are Fiberglass Bat, loose fill, and then these boards. I mean, you can go down to any hardware store and buy polyiso, or buy blue board, or even styrofoam if you want. Can't buy vermiculite. Spray foam you can buy at a hardware store. It's just you need some specialized equipment. Okay, so how do we use this? Well, we're going to use this primarily just to, if we recognize that there's a certain amount of insulation, we figure out what the R value per inch is, and then we figure out how much depth of insulation there is, and then that we can figure out the total R value of that assembly. Okay, so here's an example. If we have loose fill cellulose, and let's say it's R 3.1 per inch. Okay, and I find that we go up to an attic space and there's 10 inches of it. What's the R value and what's the U value? Really easy. If it's R 3.1 per inch, 10 inches, it's R 31. That's it. And to calculate the U value, it's just 1 divided by R, which is 1 over 31, which is 0.0323 BTUs per square foot, or degree Fahrenheit per hour. Okay, so that's your lesson on just a quick overview on different types of insulation, how insulation works, and then basics sort of how you use it and how you install those types of insulation.